Welcome to the deep dive. If you're getting ready for your ATPL theory exams, you know how heavy some of that material can be, especially instrument departure procedures. You're probably looking for, well, the key stuff, right? The clear path through all the regulations and jargon, and hopefully a way to really get it, not just memorize facts for the test. That's what we're aiming for today. We've dug into the sources, especially the one on instrument procedures, departures, and obstacle clearance. Our goal here is pretty simple. Pull out the absolute must-knows, the bits that answer those exam questions, but also, understand why things are done this way.
Yeah, and what's really interesting to me is how these procedures create this invisible net of safety and efficiency. It's what allows us to fly reliably, even when the weather's, well, not great. So we'll walk through the basics, the key terms, those acronyms, and what pilots actually need to do. Hopefully by the end, you'll feel confident with the answers because you understand the underlying logic. So where should we start? Maybe the big question, why have these procedures at all?
Good question. Yeah, why do we need such specific, sometimes complex rules for taking off? It seems like a lot.
Well, fundamentally, it's about enabling all weather operations. Taking off and landing safely when visibility is poor. Basically, when you can't just look out the window and see where you're going or what's around you. These procedures give pilots the track guidance they need and, crucially, ensure they stay clear of terrain and obstacles right after departure.
Okay, so it's really for flying when conditions are less than VMC, visual meteorological conditions. So you're flying under IFR instrument flight rules.
Exactly.
And before a pilot even starts one of these, there's a key step, isn't there?
Oh, absolutely critical. You always need an ATC clearance. Air traffic control has to clear you for the procedure. You can't just decide to fly a published departure on your own.
Right, that makes total sense. Airspace management and safety. Okay, let's talk terminology because the exams love acronyms. First one, DER. What's DER?
DR stands for Departure End of Runway. Simple as that. It's the official point where the runway pavement ends, and it's the reference point for starting obstacle clearance calculations.
Okay, DER. Got it. Next up, OIS.
OIS is the Obstacle Identification Surface. You can kind of picture it as an imaginary sloping plane extending outwards from the runway area. Anything that pokes through that surface is identified as an obstacle that needs to be considered in the procedure design.
An imaginary plane.
Okay.
And the last one for this bit, PDG.
PDG stands for Procedure Design Gradient. This is really important. It's the minimum climb gradient expressed as a percentage that the departure procedure is designed around to ensure you clear those obstacles we just mentioned.
OIS, PDG. Okay, fundamental building blocks. Good.
Definitely. Knowing those helps make sense of the next part.
Which is obstacle clearance itself. This seems like the absolute heart of the matter, right? Keeping the aircraft safe from hitting things.
It is. The whole point is ensuring you don't get dangerously close to any obstacles. This is achieved through both lateral staying on track and vertical separation. By flying a specific path accurately, the procedure keeps you within a surveyed corridor. And within that corridor, they've identified all the potential obstacles. This creates what they call the minimum obstacle clearance, or MOC. Think of it like a safety buffer.
A safety buffer. Okay, so that PDG we just mentioned, the procedure design gradient, what's the standard value pilots should assume for instrument departures if nothing else is specified?
Good question, and a key exam point. Unless the chart or procedure explicitly states a different gradient, the assumed PDG is 3.3%.
3.3%. Can we break that down? Where does that number come from?
Sure. It's not just arbitrary. It's made up of two components. The main part is a 2.5% gradient. This relates to that obstacle identification surface, the OIS, or sometimes the gradient needed to clear the most critical obstacle if it penetrates the OIS. Then on top of that 2.5%, they add another 0.8%. And that extra 0.8% is specifically there just to increase the obstacle clearance. It builds in that extra safety margin vertically.
Okay. So 2.5 for the basic slope plus 0.8 for extra safety. That makes sense. Now, another really key point, often a tricky exam question. Right at the departure end of the runway, at the DER, what is the
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.